I forgot to record this earlier, but this guy hurt himself walking. It looks very painful. So remember to always ride your skateboard.
Always ride your skateboard. So we are at the top of the pass, about to drop into Castlegar. We got about 5 kilometers to drop in, and we can charge down this whole hill. So we're dropping in at 23% charge. We can charge all the way down the slower we go. So us with the slow charger, the slower we go and the more we charge, the less time we have to spend in Castlegar, which is kind of weird. We've been coming to terms with the fact that the slower we go, the faster we get there, which strange concept. I'll explain more later. Why we stop, I know a bunch of people want to know more about the mechanics and the build of the van, so I figured I'll show you a bit about the drivetrain next, baby. Talk a bit about the motor and how I attached it. So the basics of this system, and another reason I chose the van build, is with a Ford 9-inch rear end, which is very popular with hot rodding and drag racing. There's a wide variety of gear ratios available for it. So a Nissan Leaf comes with one of 2 gear ratios, either an 8.0 to 1 or an 8.2 to 1. So the closest I could get with the Ford 9-inch, I got some 7.4 to 1 gears. That would give me a slightly higher highway speed than a Nissan Leaf and a little less torque out of the hole, but very close. 7.4 compared to 8 to 1 is very close. So because I matched the gear ratio as close as I didn't really need to run a transmission. The Nissan Leaf doesn't have gear selectors, it just has a single speed transmission. Basically I did the same, only with a rear end. So I coupled my motor directly to the drive shaft. So I did do a bit of machining for this piece here on the drive shaft to get it to couple to the spline. I used a center for a Fiat clutch, and that fit the splines of the Nissan Leaf motor pretty close. I drilled a hole in the end of the Nissan Leaf motor. Actually, I cut it off with a zip cutter first. Drilled a hole with a drill press just as centered as I could, and I had a friend machine me a piece for my drive shaft that I pressed in there, welded it in place, and just bolted it directly to the motor. Quite simply with about, well, I actually only paid $20 machine work, but he's a good old friend of mine. So for $20 of the machine work and a little welding, I mounted my Nissan Leaf motor directly to the original Ford drive shaft, of which I've replaced the U-joints and stuff, of course. I think it's a little out of balance, and that's why this van it vibrates a little more than I'd like, but I'll spend some time on that next. We'll get the drive shaft maybe rebuilt and straightened up. Straight up, Leaf motor, straight to the drive shaft to 7.4 to 1 gear ratio. It should do over 160 kilometers per hour, but I've done 145 with it, and that was scary enough with this old van. So it goes as fast as it needs, and it'll spin its tires. As far as an old van's concerned, I'm really happy with the drivetrain. Works really well. For a future episode, I'll take you through a little bit more of the electronics, the charger, the inverter, and the Resolve controller. Now I'm going to crawl out of from underneath this van. Don't watch.
Well, I managed to get it up to 50% in Castlegar before the charger closed, and we are about to attempt to cross over the pass to Selmo. It's a small pass, so it should be doable. I'm relying on our drivers,
On our math and our fractions.
Math and fractions.
Just pulling into another brake check. We're at 15% with 21 kilometers to go. A lot of it's downhill, shouldn't be a problem. You can hear the fan going right now, creeping up that hill. Finally kicked in the cooling system, which is very rare that happens. Usually the fan does nothing, but every now and then climbing up fast it'll kick in. I'm going to show you a bit about the electronics while we're here before we descend into this next hill. Welcome to my camping mess. We'll ignore the explosion that was once a week and a half of camping. And we'll pay attention a little bit to this. So this is the basic stack that runs the motor. On the bottom here, you can see here, That's the variable frequency drive. It's called by many names, but basically that's what it is a variable frequency drive. And it drives the motor through these three large three-phase wires. So it's same three-phase circuit as most industrial motors, same as most e-bikes, all the same. The same controllers will run, mosquito. Same controllers will run all of it. Then these wires here, those go down the motor for motor position. Then if the controller knows the motor's position, it can start from a stop a lot easier. And it's very important that when you build one of these, you get the motor and the inverter have to be matched out of the same car. These are programmed to the motor's recorder positions. So if you don't get them from the same card, you're going to need to get this reprogrammed. So make sure you get this and the motor from the same car. Up here is the charger and the DC-DC converter. So it pulls in our juice from our plugins and charges up the battery. It's in control of the battery. Here is our J1772, I think it's called, plug. We've been using that the whole time. This here is a Chatamo plug. This is what we wish we could have used. But I couldn't get this to work before we left, so we chanced it, went for the long haul, the slow plug. And it's been enjoyable. I don't mind the slow plug. We just spend our time at rest stops. Cooling system, this is out of a smart car, the fan, the radiator. I got this from Michael at EV West. He sent me this. He also sent me the water pump, which I believe is also out of a smart car. It's underneath. I won't take underneath there again right now, but water pump's at the bottom. It circulates water through the DC-DC converter, the inverter, and the motor, keeping it all cooled down. So if it's getting a little warm from charging, the fan will turn on, or just as now when we climb the pass, fan kick down to cool things down a little bit. This mess of wiring is pretty much all there is. It's messy, but that's it. That's everything there is to wire an EV, which is way less wires than, say, a fuel injection system on a modern car. Way less wires. So it's not very hard to wire this up. These twisted wires, very important that they're twisted pairs, and they're not supposed to run along parallel with any high current wires. They're communications wires, and they don't like magnetic fields upsetting them. So if you ever have some problems with your system, it may be that one of these is too close to a high current wire, and you just got to do a better job of routing it. Obviously, you don't have to try too hard. Down here, that's my 12-volt battery to run all the van basics. The van signal lights, headlights, tail lights, heater. I don't have a heater in this, but you need your 12-volt battery, and the DC-DC converter charges up the 12-volt battery off of the big battery. And the big batteries, of course, you can kind of see it. It's underneath where I sleep. That's the Nissan Leaf battery, just bolted right to the flat floor of the van over where the engine compartment used to be. And that's the basics of the electronics on this. There's not much to that. You can build one of these really quick if you're dedicated to the cause. Next round I'll talk a little bit more about the Resolve controller that talks to the CAN bus and makes all of this stuff work. It was built by, I always call them Swedish kids. I think they're from Norway or Sweden. Some young engineers have put together a pretty nice computer that runs my van. So I'll show you more about that next time. Thanks for watching. Got into Sama with 13% charge left. No problem. Just drive slow, do fractions. This is Salmo flow charger. These, for the most part, are free. We already know this one is because we've been here before. You need either a cell phone with fancy things on it. I don't have one of those, so I got them to send me a card. You just simply, now it tells me to plug in the connector. And try not to electrocute myself. That's alright. And that's it. Tell you your charging time. I usually have a look when we're done. Tells me how long I've been napping for anyways. So we'll be here for about 3 hours and all free thanks to the flow chargers.